Ever wondered what makes your electric toothbrush or the fan in your computer spin? The answer lies in a DC motor. In the simplest terms, a direct current motor, or DC motor for short, is an ingenious device that converts electrical energy into mechanical energy. It's a fundamental piece of machinery that powers a wide range of devices we use in our daily lives. Consider your favorite remote-controlled car or the blender in your kitchen. Guess what? They're both powered by DC motors. These versatile motors are not just confined to toys and appliances, but also make a significant presence in larger applications like electric vehicles and industrial machinery. DC motors are everywhere, silently and efficiently powering the conveniences of modern life. From the smallest of gadgets to the largest of vehicles, their influence is pervasive yet often unnoticed. So, now that you know what a DC motor is, you might be wondering, how does it work? The magic of a DC motor lies in a simple principle of physics, the interaction between magnetic fields and electric current. So let's dive into the heart of this ingenious device and see how it really works. Imagine a wire looped into a rectangle, suspended between two magnets. When an electric current is introduced into this wire, it generates a magnetic field. Now we have two magnetic fields, one from the wire and one from the magnets. These fields interact, causing the wire to spin. This is the fundamental principle on which a DC motor operates. But there's more to it. The wire is attached to a component called the commutator. As the wire loop spins, the commutator flips the direction of the current every half turn. This ensures that the wire always spins in the same direction, creating a continuous motion. Now, let's consider the permanent magnets in the motor. They're positioned around the spinning wire loop, and they serve a crucial role. Just as the Earth's magnetic field guides a compass needle, these permanent magnets guide the spinning wire loop or rotor in the motor. But how does this all result in motion? Well, the spinning rotor is connected to whatever needs to be moved, be it the wheels of a car or the blades of a fan. The rotor spins and voila, we have motion. However, it's not all about spinning. The speed of the motor can be controlled too. By changing the amount of electric current flowing into the motor, we can control the strength of the magnetic field generated by the wire. More current means a stronger magnetic field, and thus a faster spinning rotor. Less current, on the other hand, slows things down. So that's the essence of a DC motor. A clever play of magnetic fields and electric current that spins a rotor, creating motion. And that's how a DC motor turns electric energy into mechanical energy. Quite fascinating, isn't it? So, to recap, what are the main things to remember about DC motors? Well, first and foremost, let's not forget the essence of a DC motor. It's a type of machine that transforms electrical energy into mechanical energy. It's the magic behind many everyday devices we take for granted, from electric toothbrushes to car power windows. But it's not just about what it does, it's also about how it does it. The heart of a DC motor is the principle of electromagnetism. Remember how we talked about the magnetic field produced when current flows through a wire? That's the key principle that drives a DC motor. The interaction of magnetic fields generated by the current in the motor's coil and the permanent magnets surrounding it creates a force that turns the motor. Taking a closer look at the operation, you'll remember the commutator and brushes. These components are unique to DC motors. The commutator, a split ring, and the brushes work together to ensure that the direction of the current in the coil changes whenever it's about to move in the opposite direction. This change in current direction keeps the coil rotating in the same direction. A clever trick, isn't it? And then don't forget about the role of the armature, the rotating part of the motor. The armature carries the current, and it's the part that actually moves, or you could say, the part that does the motor part of a DC motor. Finally, remember that DC motors are versatile. They can run at variable speeds, and their speed can be controlled easily and accurately, which makes them suitable for a wide range of applications. And there you have it, a simple and understandable explanation of DC motors. Keep spinning the wheels of knowledge.